Alright, so last time we did solving by substitution. This time we're going to solve systems of equations by elimination. And then the last time, 2 times ago, we did solving systems and finding out their solutions by graphing. So this one is just the last method that we're going to learn how to do. So just some math stuff. We're going to be adding and subtracting 2 different equations to figure out if we can eliminate an x or a y to see if we can find the solution of the equations. So we're going to put our 2 equations on top of each other, and then we're going to eliminate. So if we look at this first one, they're on top of each other. So our first step, we have to make sure that they're lined up. It looks like these are lined up because my x's are on top of my x's and my y's are on top of my y's. Okay, my second one is to make sure that there's numbers that are the same. So for this one, our 5y and our other 5y, they both have 5's in front of the y. And the second is to make sure one is positive and one is negative. Well, one of these is positive and one of them is negative because we're trying to eliminate one of our options. So since all 3 of those are good, we're going to go ahead and just add down. And we're always going to be adding in this. So 6x plus 2x is going to be 8x. 5y plus negative 5y, well, that's going to cancel because they're opposites of each other. 17 plus negative 9 is 8. So my x should equal 1, but we always have to have a point, so we're going to pick an equation. Doesn't matter which one you pick. We're going to take the top one for this one. We're going to plug this in for my x to figure out what y is because it has to be a point. 2 times 1 is 2. Subtract 2 from both sides. 5y equals 15. Divide by 5. So y should equal 3. So my answer would be 1, 3. Again, check your answers. Plug them back in. Okay, so first step, are they lined up? Are my x's on top of my x's, y's on top of my y's? Yep. Second step, do I have a variable that has the same number in front of both of them? Well, it looks like my y's both have 2's in front. Cool. Is one positive and one negative? Yes, they are, so let's go ahead and add down. 4x plus 3x is 7x. Negative 2y plus 2y, they cancel because they're opposites of each other. 0 plus 14, 14. Let's go ahead and divide by 7 to get x by itself. And now let's plug it into one of my original equations so that we can figure out what y is because it has to be a point. I'm going to take the first one. 3 times 2 is 6. Subtract 6 from both sides. Negative 2y equals negative 6. So y should equal 3. So my point would then be 2, 3. Okay, check first one. X is on top x's, y's on top y's. Check. Do I have a variable that has the same number in front? Yes, my y's, but they're opposites of each other. One has to be negative, one has to be positive. Yes. So this one we're canceling out our y's because they're the same number, but they're opposites. One's positive, one's negative. So 5x plus 3x is 8x. Negative 32 plus 48 is 16. Divide both sides by 8. X equals 2. Got to find y. Let's pick an equation. I'm going to pick the second one this time. 3 times 2 is 6. Subtract 6 from both sides. 6y equals 42. So my y should then equal 7. So that is where those 2 lines are connecting at. To be able to do this type of equation, we have to make sure it's in standard form. Our x and y both have to be on the same side, and x has to be on top of x, y has to be on top of y. Okay. Are they lined up? X is on top of X's, Y is on top of Y's? Yes. Do we have a variable that has the same number in front? Well, my X's do. They both have 3's. Is one positive and one negative? Yes, it is. So let's go ahead and add. This time our X's will cancel because they're the ones that are the same number but opposite. So negative 3y plus negative 4y, negative 7y. 9 plus 5 is 14. Divide by negative 7. Y should equal negative 2. Let's go ahead and pick an equation to put it in. Negative 4 times negative 2 is a positive 8. Subtract 8 from both sides. We're going to have 3x equals negative 3. Divide by 3. X should equal negative 1. All right. Are they lined up? X on top X, Y on top Y? Yes. Do I have a variable with the same number in front? Y does. They both have 3's. Cool. Is one positive, one negative? Yes. Awesome sauce. So let's go ahead and add. Our Y's will cancel this time. 3x plus x is 4x. 27 plus negative 11 is 16. Divide by 4. X equals 4. Plug it into an equation. Let's try the bottom one. Subtract 4 from both sides. Negative 3y equals negative 15. Divide by negative 3. Y should equal 5. All right. So step 1. Are they lined up? X is on top of X's, Y is on top of Y's. Yes. Do I have a variable with the same number in front of both? Ooh, I don't. My X's don't share the same number, and my Y's both don't share the same number. So we got to make it so that they both have the same number in front. So let's look at if we cover up this. How would we get our X's to be the same? Well, we can multiply the top by 2 so that they both are 8. So we're going to multiply all of it by 2. If you're going to do one thing to it, you have to multiply all of it. So we're going to get 2 times 4x is 8x. 2 times negative 7y is negative 14y. And 2 times 15, don't forget that last number, is 30. We're going to rewrite this bottom one. Okay, now we can add. So we have the same number in front, and they're opposites of each other. One's positive, one's negative. So we know our x's will cancel. Negative 14y plus 14y, that also cancels. And 30 plus negative 30 also cancels. So does 0 equal 0? Yeah. So our answer for this is going to be infinite. If they didn't equal each other, it would be no solution. Kind of like what we were doing on when we were using substitution to solve. Okay. So, 1, are they lined up? X is on top of X's, Y is on top of Y's. Yes. Do I have a variable with the same number in front of both? No. So, let's cancel our Y's this time. So, you can pick either your X's or your Y's to cancel, and you'll get the same answer. So, let's go ahead and cover up these. How would I get my Y's to match? Well, we can multiply the bottom by 2 to get them to match. So we're going to do 2 times x is 2x, 2 times 3y is 6y, and 2 times 9 is 18. So we're good with that. But are they opposites? Is one positive and one negative? No. So now we need to multiply this one by negative 1 to get them all to be negative. So we're going to get, I'm going to do it up here. So we're going to send that negative through, so we're going to get negative 2x minus 6y equals negative 18. So 2x minus 2x is 0. 6y minus 6y is 0. 18 minus 18 is 0. 0 equals 0, so our answer for this is going to be infinite again. All right, are they lined up? X is on top of X's, Y is on top of Y's. Yes. Do they have the same number in front of one of the variables? No. So let's take a look at my X's first. If I wanted them to be the same, I'd have to do a lot of multiplying. So we could have done multiply the top by 7 and the bottom by 2 to get them to be the same by getting them to be 14. But let's take a look at the Y's and see if they're easier. It looks like we can multiply the bottom by 3 and then we'd get 15 for both, and one would be positive and one would be negative. So let's go ahead and do that. So we get negative 2x plus 15y equals negative 32. 3 times 7x, 21x. 3 times negative 5y, negative 15y. And 3 times 17 is 51. So, 2. Our y's are the same now. They both have 15s. And 3, one's positive, one's negative. So we can add now. 21x plus negative 2x is 19x. Our y's cancel. 51 minus 32, we're going to get 19. So x will equal 1. Okay, now we got to plug it into one of our original equations to find y. So let's plug it in to the bottom one. 7 times 1 minus 5y equals 17. 7 minus 5y equals 17. Negative 5y equals 10. So my y should equal negative 2. So if I plug those in, they should be equal to each other. Okay, step 1, x is on top of x's, y is on top of y's. Boom. Step 2, do I have two numbers that are the same? It doesn't look like it. Let's check out our x's. Well, it looks like a GCF that they share would be 15, so I'd have to multiply the top by 3 and the bottom by 5. But let's check out our y's. It looks like we can multiply the top by 3, and then they would both be 6, and one would be negative and one would be positive. So let's do that. So I'd get 3 times negative 5x, negative 15x. 3 times negative 2y is negative 6y. And 3 times 2 is 6. So let's go ahead and add. Negative 15x plus 3x is negative 12x. Our y's cancel. 6 plus 6 is 12. Divide by negative 12. X should be 1. Got to find our y. Let's plug it in. Let's do the top one. Make sure you're plugging it in for the x value. Negative 5 times 1 is negative 5. Add 5 to both sides. Negative 2y equals 7. Divide by negative 2. Y equals negative 7 halves. Okay, first step. X is on top of x's. Y is on top of my y's. Cool. Do I have a number in front that they both share? Let's check out my x's. Looks like I'd have the GCF that I could get them to both be would be 12. That would be pretty easy. So I'd have to multiply the top by 4 and the bottom by 3. Let's check the other one to see if it'd be easier. Well, it looks like they could get to 6, so I'd have to multiply the top by 3 and the bottom by 2. So let's go ahead and try to get our y's to cancel. So let's multiply this top by 3. So 3 times 3x is 9x. 3 times 2y is 6y. And 3 times 1 is 3. Okay. So we still need the y's to cancel, so we have to have the bottom one multiplied by 2 so that they be the same. But one has to be positive and one has to be negative for them to be canceling. So let's multiply the bottom by negative 2. Negative 2 times 4x is negative 8x. Negative 2 times 3y is negative 6y. And negative 2 times negative 2 is 4. 9x plus negative 9x is just x. Y's cancel. 3 plus 4 is 7. X equals 7. Gotta still find y. 7 times 3 is 21. Oops, that's a y. Subtract 21 from both sides. 2y equals negative 10. Divide by 2. Y should then equal negative 2. So my point would be 7, negative 2. So you're able to multiply the top by something and the bottom by something to get either my x's to cancel or my y's to cancel. It doesn't matter which one you get to cancel for those. You'll still get the same answer. Just make sure that one of them is positive, one of them is negative, and they're the exact same number. Okay. Are they lined up? Yes. Do I have two that have the same number? No. So let's take a look at our x's. Let's go ahead and try our x's, because it looks like we can multiply the top by 3 to get them to try to be the same, but one of them has to be negative, so let's multiply it by negative 3. Negative 3 times 2x is negative 6x. Negative 3 times negative 5y, 15y. And negative 3 times 17 is negative 51. Go ahead and add. Negative 6x plus 6x is 0. 15y plus negative 15y is 0. Negative 51 plus 51 is 0. Does 0 equal 0? Yes. So our answer is infinite. Okay. X's on top of x's, y's on top of y's. Boom. Do I have a variable with the same number in front? Well, yes, I do. Let's look at our x's. They both have 9s. But is one positive and one negative? No. So let's multiply negative 1 through one of them. Negative 1 times 9x gives me negative 9x. Negative 1 times 8y, negative 8y. Negative 1 times negative 16, positive 16. 9x, oh, now we have one positive, one negative, so we're good to go. 9x plus negative 9x is 0. 8y plus negative 8y is 0. 15 plus 16 is 31. Does 0 equal 31? No. So my answer then is no solution. Okay, so first step, are they lined up? Oh, lordy, no they're not. So let's go ahead and distribute. So we get 5 times 2 is 10. 5 times negative y is negative 5y. Got to distribute for this one too. 3 times negative x is negative 3x. 3 times 5 is 15. Are my x's on top of my x's, y's on top of my y's, and they're both on the same side? No. So let's add 5y and also add 3x. So then we'd get 2x plus 5y equals 10, and 3x plus y equals 15. Now my x's are on top of my x's, y's on top of my y's. So my second step, do I have a variable with the same number in front of both? No. But it looks like if I try my y's here, I can multiply the bottom by negative 5 to get them to be the same number but opposites. So we're going to have 2x plus 5y equals 10. Negative 5 times 3x is negative 15x. Negative 5 times y, negative 5y. And negative 5 times 15 is going to be negative 75. My y's can now cancel, so we can add. Negative 15x plus 2x is negative 13x. 10 plus negative 75 is negative 65. Got to get x by itself. 65 divided by 13 is 5. But now I got to find y, so let's go ahead and plug it into my second equation. Negative 5 plus 5 is 0. 3 times 0 is 0. So my answer should be 5, 0. Again, plug it in and check to make sure that they equal.